We're gonna break down Angular for React developers, translating familiar concepts like reactivity, templating, lifecycle methods, and component composition into Angular's world. Whether you're a React pro looking to expand your skills or just curious about Angular's power, this video got you covered. By the end of this video, you won't just understand Angular, you'll be able to start coding with confidence. In our React example, we imported the useState hook to manage state. We initialize our state variable name with John and then directly render it. This approach leverages hooks to trigger re-renders when the state changes, making the component reactive and easy to manage. Now let's switch gears to Angular. Here we use Angular's new signal function. In our component, we declare name as a signal with John as its initial value. In the template, we call this signal like a function to get its current value. Let's dive into updating state in both React and Angular. In the React example, we start with the name state initialized to John using useState. Then, with useEffect, which runs once when the component mounts, we call setName to update the value to Jane. This change triggers a re-render, so your component now displays Hello Jane. Switching over to Angular, we initialize a signal named name with John. In the component's constructor, we immediately update the signal by calling this.name.set Jane. The template then retrieves the updated value by invoking name, and it too displays Hello Jane. In this example, we're exploring computed state in both frameworks. We start by initializing our state variable count with a value of 10 using useState. Then we derive double count simply by multiplying count by 2. Every time React re-renders, this computed value is recalculated, ensuring our UI always displays the latest result. Here, we initialize a reactive signal called count with the value of 10. Instead of manually computing a new value, we define double count using Angular's computed function. This creates an automatic dependency on count. Any change to count instantly updates double count, keeping our template in sync effortlessly. Let's take a look at the minimal template example for both frameworks. Here we have a simple functional component named Hello World. It directly returns a JSX element, an H1 with Hello World. This straightforward approach is perfect for small components that don't require any additional logic or state. In Angular, we define a component with the addComponent decorator. The metadata includes a selector and a template property containing the same Hello World markup. While this setup is slightly more verbose, it establishes a clear structure for larger, more complex applications. Let's compare how styling works in React versus Angular. In a React example, the component imports an external CSS file. Notice how we use class name to apply a CSS class. The H1 element gets its red color from the external style sheet, while the button is styled inline using a JavaScript object with camel case properties, in this case setting font size to 10 rem. This approach gives you the flexibility to mix global and inline styles in a component-based architecture. Now in the Angular example, the component is defined with an inline template and styles via the addComponent decorator. Here, the H1 uses the standard HTML class attribute to pick up the red color from the component's encapsulated styles. The button is styled directly using an inline style attribute within the template. Angular's approach bundles the component's template and its styles together, helping to ensure that styling remains localized and avoids global conflicts. In our React example, the colors component defines an array of colors and uses the JavaScript map method to iterate over each color. For every color, it returns a list element and assigns a unique key, a crucial step for React to optimize rendering. This approach leverages native JavaScript functions to dynamically build your list. On the Angular side, we also declare an array of colors in the component. Instead of JavaScript's map, Angular uses a custom @for-loop syntax in its template to iterate over the array, along with the tracking expression. Now, let's dive into a simple counter example and see how React and Angular handle state updates. We begin with the useState hook, initializing our counter to 0. The increment count function uses the state setter to increase the count by 1, leveraging a callback to ensure the previous value is correctly updated. When the button is clicked, React re-renders the component, showing the updated count. In Angular, you'd typically declare a signal for your state, like count equals single zero. Then, you define an increment count method that updates the signal, using either a direct set or an updated function. In the template, an event binding on the button triggers this method, and the updated count is automatically reflected by calling the count function. In React, we use useRef to create a reference to our input element. When the component mounts, useEffect runs and calls focus on the referenced input, ensuring it's ready for user input right away. Switching to Angular, we achieve a similar result with a slightly different approach. The component defines a viewChild reference tied to the template's input_ref. Then, using afterNextRender, Angular waits until the view is fully rendered before invoking focus on the element. In this example, we're comparing conditional rendering using a traffic light scenario. Our React component uses the useState hook to track the current light index. It selects the current light from an array and then uses inline conditional expressions, leveraging short-circuit evaluation to display the corresponding message. If the light is red, it shows stop. In Angular, we similarly manage state with a reactive signal for the light index and compute the current light. However, instead of inline conditions, the template uses a declarative switch directive. Each case directive block handles a specific condition, rendering the appropriate message based on the current light value. This switch case style offers clarity, especially when handling multiple conditions. Let's see how each framework handles actions when a component mounts. In our React example, we use the useEffect hook with an empty dependency array, ensuring it runs only once, right after the component mounts. Inside useEffect, we capture the document title and update our state via setPageTitle. This triggers a re-render. Angular achieves a similar result by implementing the onInit lifecycle hook. Inside the ngOnInit method, we set our reactive signal pageTitle to the document's title. The component's template then calls pageTitle to display the title. In this example, we see how both frameworks handle cleanup when a component unmounts. Here, the time component uses the useEffect hook to start a timer that updates the current time every second. The hook returns a cleanup function that clears the interval when the component unmounts, preventing potential memory leaks. The time component initializes a signal for the time and starts an interval in the component body. By implementing the onDestroy lifecycle hook, Angular calls ngOnDestroy when the component is about to be destroyed, where we clear the timer. In this example, we're comparing how external data flows into the components. The app.jsx file passes props like name, age, favorite colors, and is available directly to the user profile component. Inside userprofile.jsx, these props are received as function parameters. We even use prop types to enforce type checking. Similarly, in Angular, app component embeds the user profile component in its template, passing data via attribute binding. The user profile component then declares its input using the input decorator, which, thanks to Angular's reactive signals, allows us to access these properties dynamically in the template. Let's compare how both frameworks handle child-to-parent communication. In our React example, the parent component manages a state variable, isHappy, using useState, defines two callback functions, onAnswerYes and onAnswerNo, to update the state. These functions are passed as props to the answerButton component. When a user clicks either button, the corresponding callback fires, updating the parent's state and re-rendering the smiley face accordingly. Angular takes a slightly different approach. The app component holds a reactive signal, isHappy, and defines methods onAnswerYes and onAnswerNo that update it. The child component, answerButton component, emits custom events using output bindings, here represented by yes and no. In the template, the parent listens to these events with yes equals onAnswerYes and no equals onAnswerNo, triggering the appropriate state update. Let's compare how both frameworks handle component slots, a powerful way to create reusable components that accept custom content. In React, the funny button component leverages the children prop. Whatever you nest inside funny button in the parent component becomes accessible as children within the component. The component then renders the custom content inside the styled button element, making it highly reusable. Angular accomplishes a similar goal with content projection using ng content in the template. When the parent component wraps content within app funny button, Angular projects that content into the designated ng content slot. Let's explore how both frameworks handle slot fallback when no content is provided. In React, the funny button component uses the children prop to render content inside the button. If no children are passed, the expression children or span with no content provides a fallback message. This approach leverages JavaScript's logical OR operator to ensure that the button always displays a default message when needed. In Angular, content projection is achieved with ng content. By passing fallback content between the ng content tags, Angular automatically displays no content found when no content is projected by the parent. Let's explore how both frameworks handle context sharing. In React, we create user context and wrap our user profile with a provider in app.jsx. This provider passes down the user data along with an update username function. Inside user profile, we use useContext to extract these values, and the button click triggers a state update that seamlessly refreshes the UI. Angular, on the other hand, leverages dependency injection through user service. Root app component and user profile component inject this service. The service holds the user data as a reactive signal and provides an update username method, ensuring that any change is automatically reflected across components. In our React example, we manage form input using a controlled component. We initialize a state variable called text with hello world using useState. The input's value is bound to this state, and every keystroke triggers handle change function, updating the state with the current input via event target value. This pattern ensures that our UI and state remain perfectly synchronized. Switching to Angular, we utilize two-way data binding with ngModel. Here we define a reactive signal for text. By binding the input with ngModel, Angular automatically updates the signal as the user types, and the updated value is rendered in the template using text. This declarative approach simplifies state management by keeping the component's data and view in constant harmony. In our React example, the isAvailable component manages a checkbox state using the useState hook. When the user toggles the checkbox, the handle change function is triggered, flipping the isAvailable state between true and false. The checkbox's checked attribute is bound directly to this state, ensuring the UI always reflects the current value. In Angular, the isAvailable component leverages Angular's two-way data binding with ngModel, enabled by the forms model. Here, the checkbox binds to a reactive signal called isAvailable. Any change to the checkbox automatically updates the signal, and vice versa, without requiring explicit event handlers. In our React example, the pickPeel component uses useState to manage which peel is selected. The initial state is set to red, and when a radio button is clicked, the handle change function reads the new value from the event and updates the state accordingly. Each radio button's checked attribute is determined by comparing its value to the current state, ensuring that the UI always reflects the correct selection. Switching over to Angular, the pickPeel component takes advantage of Angular's two-way data binding with ngModel. The component defines a reactive signal called picked, also initialized to red. By binding ngModel to picked, any change in the radio button selection automatically updates the signal, and the template displays the updated value without the need for explicit event handlers. Let's break down the select input examples. In our React example, the color select component defines a list of colors, each with an ID, text, and an optional disabled flag. We initialize state with useState, setting the default selection to the color with ID2, blue. The handle change function reads the selected option's value and updates the state accordingly. Using the map method, each color is rendered as an option, where properties like value and disabled are dynamically assigned based on the color data. Switching to Angular, the color select component uses Angular's reactive signal to manage the selected color ID, also starting at 2. The template employs two-way data binding with ngModel, ensuring the component state is always in sync with the select element. Angular's custom @for loop iterates over the colors array, and property binding like value and disabled are used to render each option correctly. If you found this video helpful, make sure to subscribe to my channel so you never miss out on valuable content. Thanks for watching, happy coding, be seeing you in the next one.